Section 5.4, Average Cost. I'm interested to know how much does it cost on the average to produce Q some amount of items. We're going to take a look at that in this section for the next few minutes. C of Q could be a cost function. If I divide that by the quantity Q, that's going to give me my average cost. Average cost is the cost per unit of a certain quantity, whereas marginal cost is the cost of producing the next one. Marginal cost is from your derivative, it's the slope, versus average is how much does it cost on the average. You can see that from the following equation. Let's let average cost be A of Q. If I take C of Q and divide by Q, I'll have a formula for average cost. Let's look at an example. Here I've given you an equation for a cost function. And this is representing the amount of money it's going to cost to produce an iPhone. I want to know the average cost of producing 100 iPhones and the marginal cost of the 100th iPhone. To find the average cost, I'm going to start by finding the cost of making 100 phones. Now, I'm simply just going to plug in 100 for all the values of Q in the equation that you see. So when I do that, the C of 100 is going to be $6,300. I now want to divide that value by 100 to get the average cost. So A of Q is going to be, take C of Q, my 6,300, divide it by my 100, and I'll get $63. So this is saying that on the average, if 100 phones are produced, it's going to cost me $63 per phone. So now let's move on to finding the marginal cost of the 100th iPhone. Marginal cost, I said, comes from the derivative C prime of Q. Well, let's go ahead and take a second to find the derivative of the cost function. Using the power rule, I have the equation for C prime of Q. Now I want to evaluate that equation for a value of Q of 100. So plugging in a 100 for C prime will yield the result of $193. The interpretation here is once I've made 99 phones, it's going to cost me an additional $193 to produce the 100th iPhone. So here you see the difference between the average cost versus the marginal cost. The cost per average for each phone and the cost to make an additional phone. In this example, I would like to know which Q value would yield the lowest average cost. I have dollars for my vertical and quantities on my horizontal, and a cost function in blue. To answer this question, I'm going to connect a horizontal line from the origin to each of the Q values connecting to the cost function. These are the average costs for each of those quantities. The cost fluctuates up and down in blue, and if I connect from the origin up to the blue on Q1, that's how much it would cost on the average. The lowest average cost is going to be the three of these green lines with the smallest slope. In this case, that's going to happen at Q2. Here's my next example. Let's suppose that I have 100 items being produced with an average cost of $2 per item. I want to find the average cost of making the 101st item, and then the marginal cost to make the 101st item. If it is A, $1 versus B, $3. So the average cost of making 100 items given in the problem was $2. If I want to know the cost of making 100 items, if it's $2 on the average times 100 items, that would be 200. The cost of making the 101st item using the marginal cost of $1 would be an additional dollar to the 200, or in this case, 201. My new average cost is going to be my cost function divided by my quantity, 201 divided by, I am now making 101 items, and this is going to give me $1.99. Now let's look at the same situation if the marginal cost were $3. The average cost of 100 is still the same value of 2. The cost to produce 100 items is still $2 per item on the average, multiplied by 100 of them would be 200. The cost to make 101 items, if the marginal cost is $3, that's an additional $3 on top of the 200, 203. And now my new average cost, C of Q over Q, would be 203 divided by 101, $2.01. In part A, the marginal cost was less than the average cost. And if you notice what that did to the average cost, it reduced it to $1.99, down from $2. In the second situation, the marginal cost was more than the average cost, and that increased the average cost up to $2.01 from $2. That's always going to happen. If your marginal cost is less than the average cost, it's going to reduce the average cost. If your marginal cost is more than the average cost, it's going to increase the average cost. When marginal cost equals average cost, that's going to be a critical point of average cost. And average cost is going to be minimized. Let me give you a second to write all that down. Those relationships are fairly key. Let's look at one last example. Here I've given you a cost function, but this time I have a condition where I can only produce between 0 and 5 items. So let's graph C of Q, but using derivatives, not a calculator. The first thing I'm going to do is take the derivative and then look for any critical points. So I'm now going to factor this and set it equal to 0. And you can see that I do have a critical point at x equals 2. From what we learned previously, that may or may not be a max or a min. It may or may not be an inflection point. So let me go ahead and find the second derivative and set that equal to 0. And when I do that, I get the same quantity of 2. So now I know that the critical point of Q equals 2, that is indeed not a max or a min. that it's going to be an inflection point. This should help me graph. Keep in mind I do have to graph from 0 to 5. When I do that, I will get the following. So after using some test points on my sign charts for C prime and C double prime, I will come to the following. I know that there's an inflection point at 2, and I also know that the slope of the derivative is 0 here. If I plug in points to the left of 2 into C double prime, I'll get negative values telling me that C double prime indicates that the original function is concave down. I then hit my inflection point, plug in a point from 2 to 5 into C double prime, and I'll get a positive value telling me that it's concave up. And I do have a point here at 5, not an arrow, because I'm restricted from 0 to 5. Let's also find the average cost of this function. Average cost is going to be C of Q over Q. So I'm going to write the cost function and then divide that by Q. Conveniently, there's a Q in each expression of the cost function, and I can reduce this to the following. I'm simply dividing out a Q or factoring out a Q. And I have my average cost function, Q squared minus 6Q plus 12. And lastly, now I want to know, when does C prime, marginal cost, equal the average cost? Well, just simply set those two equations equal to each other. And then with a little bit of quick algebra here, you will find out that Q will equal 0 and 3. So when is average cost minimized? That's going to happen at these two values, 0 and 3. And that pretty much wraps up this section on average cost. Thanks for watching.